Okay, this is day 3 homework of Unit 5, Lesson 1. This comes from page 337. This is question number 4. So we're going to take a look at it, and the question says, without using a graph table or a CAS, find all zeros of these functions. So we're just going to find the zeros, and the zeros are easy to find if it's in factored format, and each of these appear to already be factored. So 4a reads that f of x is equal to x minus 3 times x plus 4. And so the zeros of a function are where this is going to equal 0. What x values will cause this to equal 0? Well, that happens when each of the factors is set equal to 0. So I could set x minus 3 equal to 0 and x plus 4 equal to 0. And when I solve these, I'd find that x is equivalent to 3 or x is equal to a negative 4. And both of those would give the zeros for this function. See how nice that is? The zeros are opposite the factors. That's great. Easy to remember. And so I go to part B. I have g of x equals x squared minus 9 times x. Now, it's a little tricky because there's actually a quadratic built into this as a factor of this. So we actually have to do is set two things equal to 0 here. X squared minus 9 equals 0, or x equals 0 on its own. And sure enough, there's one of my solutions, x equals 0. But this part, x squared minus 9 equals 0, should also be factored if we can. And I notice this is a difference of two perfect squares. X squared is a perfect square, 9 is a perfect square. So this factors into x minus 3 times x plus 3, which if that's supposed to equal 0, that means that x minus 3 equals 0, or x plus 3 equals 0, which means x equals 3 or x equals a negative 3. So I have three solutions. X is 0, x is negative 3, x is positive 3. Okay? Make sure I circle my solutions from the previous part on A. C. H of x equals x squared plus 5, and then times x squared again. Now again, to find the zeros for this function, I want to set each of these factors equal to 0. And if x squared itself is equal to 0, that means that x is actually equal to 0 again, because 0 squared is the only number you can square and get 0 out. So x is equal to 0 is there. And in this part, x squared plus 5 equals 0, I'm actually going to have to use a little algebra here. We'll subtract 5 to get x squared equals a negative 5. But then I notice something. X squared, negative 5. When I start to root this, if I try to take the square root of a negative 5, I get out a non-real answer. So this is actually a non-real answer. So there are no more real zeros in that one. And since it's asking for the zeros of these functions, the only zero that's going to come out is at x equals 0. We can call these non-real roots, but non-real roots won't show up on a graph as zeros, so I don't need to supply those as answers. Look at D. We have D is equal to t plus 5 squared. Now equivalently, that's also t plus 5 times t plus 5. We want that to equal 0 in this case. So we have to find solutions to where t plus 5 equals 0. That's easy enough. It's opposite the 0 as t equals a negative 5. And that is the only 0 that shows up. It's actually a multiple 0, a 0 that shows up with a multiplicity of 2. So what we see about that, though, is it actually shows up in a graph as one intercept. It's just this graph has a minimum point at negative 5, 0. Kind of neat. All right, that ends question number 4.